Good evening. I'm John Walsh, the director of the Getty Museum. I want to welcome all of you here to the museum and tell you that I'm delighted you're here. Also to remind you that you have the galleries all to yourself. Ask you just not to take anything home. Galleries are on two levels. You saw the first floor with antiquities upstairs, the rest, paintings, furniture, sculpture, manuscripts, photographs, drawings, and the like. We feel lucky here at the Getty that we can be hosts to a fundraising event for Earthwatch because Earthwatch is such an inspiring organization. We admire it for lots of different reasons because it sponsors such a great deal of valuable field work. In our case, particularly the sort of marvelous archaeological projects that you'll be hearing about from Dr. El-Baz in a minute. We admire Earthwatch because it changes the lives of so many people in the process. We're also impressed by Earthwatch because it's a kind of wonderfully efficient money pump. The sort of thing that J. Paul Getty would have admired a lot. It extracts the stuff from down deep in your pockets and out of the pockets of business and foundations and pumps it right to where it's needed most, on the frontiers of research that can perhaps make life on this earth more interesting and last longer besides. At Earthwatch, very little goes to waste. Everybody gains, and a great deal of fun gets had in the process. It's really my job here to introduce Brian Rossborough, the president of Earthwatch, a perpetual motion machine who powers that money pump, sometimes has to grab the handle himself to keep things gurgling along. Knowing him fairly well as I do, I envy you, all of you, for having him at Earthwatch. I've been charged up myself by his energy, challenged by his curiosity, entertained by his off-center view of the world, and inspired by his strong faith in people and good ideas. I'm very pleased that Brian Rossborough is here at the Getty tonight, and I'm honored to introduce him to you. Brian Rossborough.
Thank you very much, John. You're as generous with your introductions as you are with your art resources. And thank you all for coming. I've met about 20% of the audience outside, and I hope to see all of you before the end of the evening. We're really pleased to have you come here because it's a special occasion. This is not our first occasion to work with the Getty Conservation Institute. One of their curators, Marilyn Schmidt, who might be in the audience, before she was here, we were able to support in her work on Romanesque reliefs in France. And a professor, Dr. Baroff, who's no longer here, came to us years ago with his plan to do some work on the mosaics of Caesarea Martina, and many of you might have worked on either of those projects. It's my joy to give you some perspective on what we did, but our guest really will do most of the heavy lifting tonight. And it is customary with any expedition to tell you what underpins it, but particularly an event like this, which celebrates a single project, could not have been done without the extraordinary work of many, many people. So one of the things I would love to do is to tell you how involved all of you are in that work. Our special association here, as you know, is with the Getty Museum, but the Getty Conservation Institute, who's the collaborator on the project with the Egyptian Antiquities Organization. Earthwatch is staffed and managed in California through the help and support of a number of you represented here. Your contributions this evening in support of this event match those of the James Irvine Foundation and the Atlantic Richfield Foundation and their initiation of a minority scholarship program. I don't know if you know, but in addition to producing expeditions, Earthwatch has funded about 3,000 teachers and students over the years with the help of sponsors like yourselves who've joined our projects. Representatives of the Amundsen Foundation are supporting some of this evening's work. My great colleague, Frank Arensberg, who helped us when when we were approaching extinction years ago has come, Moribulus. The Ludwigs, who are good friends, and you may know, have been supporting the Theban necropolis mapping project for Berkeley. You've read about it in the papers, the discovery or rediscovery, as the Egyptians say, of some of the tombs. Professor Kent Weeks and the Ludwigs are here, and also our good friends Kitty Keck and Steve Moses, who represent in part the Mead Foundation. I'd like to thank all of you, our special guests. I look around the audience. There are a number of anthropologists, Danya Hansen. I see Barudi Galdigas, who I've just heard her talk at the National Geographic last week, so that we're here, a collection of curious scientists and members and sponsors, which is really what Earthwatch is all about. On a continuum, I find ourselves somewhere between the Getty Museum and Huckleberry Finn. Our balance sheet is a little closer to Mr. Finn. We're now, as you know, nearing 20 years, in our 17th year. The notion of Earthwatch came about at a table. I'd been an investment banker and was mistakenly invited to a table of scientists who were trying to find some support years ago to underwrite a single expedition in the Sahara Desert, which is, I think I like deserts and volcanoes. And Dr. Donald Menzel from Harvard College, and as they thought mistakenly either I had the funds or knew where to find it, both of which were not true. But I was fascinated as to where the resources come to mobilize some of the intellectual capital of our society. Where do you find the support for academic entrepreneurs, the intellectual enterprise that's going to tell us all how to solve some of the engaging problems which face our generation? And I learned that there are very few sources of support, largely governmental. And coming from another world, I thought, gosh, why can't you syndicate that kind of excitement? And that really was the genesis of what now you all know as Earthwatch. And I think dutifully our great managers and supporters and the progenitors of this evening, Jill Walsh, Linda Knight, and Sandra Hoffman, who have gathered us all here, have packaged up for all of you a 5-year retrospective on the work of the organization. Let me tell you a little bit about how an expedition starts. We get about 400 proposals a year currently, and after peer review, are supporting about 100 projects. This project came on a phone call from a good friend of mine in Boston, whom some of you know, Dr. Bradford Washburn, who's the cartographer who puts those wonderful maps occasionally in the middle of the National Geographic. Brad Washburn was the director of the Museum of Science, and he says, did you know that there's a distinguished Egyptian scientist living near you in Concord, Massachusetts? Which, of course, I didn't know. And he said that he's got a fascinating project, and I was introduced at that moment to our guest this evening, Dr. Farouk El-Baz. Farouk brings special energy to a problem which is unique. For those of you, I don't know whether you remember John Romer's wonderful book, Ancient Lives, where he talked about Thebes, if I can remember it, being the altar where the arc of the sky meets the curve of the earth, in a landscape so vast you can't comprehend it, yet so small that you can cross it in less than an hour. That was the site of this special project. And the mission was simply to make a map, a cameo role in a larger drama that involves our special stewardship for those antiquities. If you can imagine 4,000 years of this treasure, with 120 years being the occasion, the window view of Western man being able to go back to this art that's been preserved by nature and by weather conditions, and to discover that in many of the cases these priceless treasures are threatened. And so what is happening here is that an alliance between scientists and artists working together are trying to approach this problem. Dr. El-Baz is uniquely qualified as the principal investigator of the Nefertari expedition. We know him today as the director of the Center for Remote Sensing in Boston University. but he's a geologist. He's a specialist, really, in arid lands. He studied at Anshan in Egypt, also the Missouri, I think it was, yeah, Missouri School of Mines, and the Massachusetts Institute of Technology. He taught at the University of Heidelberg and also Asyut University in Egypt. And then, for many years, 6 years, was associated with the American space program as Secretary of Lunar Landing Sites, the principal investigator for all the visual observations, and the trainer of the American astronauts. Dr. El-Baz is known in his country as the man who put the man on the moon. During this time, he managed to find time to found the Center for Planetary Studies at the Smithsonian. He was a pioneer in the use of space photography to assess arid lands and the evolution and change in desert lands, and the assessment of desertification, which is rapid all over the country. And he was devoted to the late President Anwar Sadat of Egypt as the science minister of that country. Please welcome, with me, Dr. Farouk El-Baz.
Thank you very much, Brian. Ladies and gentlemen, it is certainly delightful to be with you here tonight. My introduction to Earthwatch, even though I was introduced to Brian, my fellow Concordian, not too long ago, my introduction to Earthwatch really goes from the very beginnings to our mutual friend Donald Menzel, the professor at Harvard, was also the chairman of a group that belongs to the International Astronomical Union that was responsible for naming all of the new features in the solar system. And he was the chairman, and I was responsible for the naming of new features that we observed or found on the moon. So in the 1973, when he was preparing to go to follow the solar eclipse in North Africa, he started talking to Brian about the potential for getting this together. He talked to us a great deal about this at the time, and so I have some knowledge of the beginnings of Earthwatch and its purpose and the initiatives worldwide. And for this reason, I'm definitely a supporter of Earthwatch. I have been a member for many years, and definitely a happy participant in the Earthwatch programs. In addition to having been a principal investigator of Earthwatch, we're also, because of the neighborhood in Boston, a lot of things that happen at Boston University Center for Remote Sensing are exposed to the Earthwatch people, and we're talking to Brian these days about the potential of having the equipment and the computers and the facilities that we have at Boston University to be available to Earthwatch principal investigators and so on, for somebody that would like to process a space photograph of their area before they go and things like that, would be able to offer this kind of service or support. This evening is especially delightful because of the fact that it includes a discussion of a topic that is very close to my heart, both as an Egyptian or as a scientist of Egyptian origin. The reason for that is that it is a joint research program between Americans and Egyptian scientists. And the setting, as far as I'm concerned, couldn't be better than the Getty Museum, one of the most wonderful places in Los Angeles. And this particular beautiful day or the beautiful evening, John Walsh, thank you for ordering a wonderful evening for us too, to enjoy the grounds. And before I start, I must say that I certainly, although this was my first trip to LA for Earthwatch, I'm definitely very highly impressed by the caliber and the support of Jill Walsh and Linda Knight and all of the Earthwatch people in LA, whose magnificent organization of this evening shows very clearly. Now I'd like to talk a little bit about the research project that started last fall, which is named the Wall Paintings of the Tomb of Nefertari. It's a joint research operation or project conducted by the Egyptian Antiquities Organization and the Getty Conservation Institute here in LA. And the objective of this research program is to discover the causes of deterioration of the wall paintings of the tomb and suggest methods of restoration of these paintings so the tomb can be opened for tourists in the near future, because the tomb has been closed to visitors because of the fear that people, as they go in, they might disturb it, and there are some paintings that are hanging by a thread, so to speak, and there is fear that some of these things would be further deteriorated by people walking into the tomb. So the research project is interdisciplinary in nature. Scientists, geologists, engineers, artisans, conservators, chemists, stratigraphers, people from all different walks of life work together, each one coming with his experience, his or her experience, and talking about what we see collectively. And so it is a very interesting example of interdisciplinary or multidisciplinary research. What I would like to do is to summarize the whole program for you, and then emphasize the part that Earthwatch played with the, actually still plays with the volunteers, and I will start with showing some photographs. Next, the photographs, please start. Many people have said that the Earth is what we see from above today, and indeed, if one looks at the Earth, you can see magnificent things, and the photograph that we're looking at now was taken by the Apollo 11 astronauts. And as they finished their job and on their return journey from the moon to the Earth. And we see all of the continent of Africa and quite a bit of Asia. There is Africa right here. So this is the Red Sea, and this is the Mediterranean and the Persian Gulf, and quite a bit of and we see this enormous desert belt. It was interesting that the astronauts used to say that the desert area, particularly that one, is the only one they could see from the moon and make out the land. Basically because of the lack of any cloud cover, so everything else nearly is cloud covered, and the areas that are heavy with vegetation, the color is so dark that they look very much like the waters around. Here's the Indian Ocean or the Mediterranean and the Atlantic. In addition to that, since this area here does not receive any rain or much rain at all today, then it is not covered with vegetation, and the rocks and the soils are very highly exposed, and therefore they emit or reflect quite a bit of the solar radiation, and therefore we can see them very clearly. In the photograph, we can see the Nile Delta and just a little bit of the Nile. The eastern part of the Sahara, which is right here, is in the heart of this belt of desert. This particular desert is exceedingly arid and very dry. In studying the deserts of the Earth, we wanted to evaluate the differences between deserts. How dry is dry? We found out that we can make an aridity index, which is something that relates the solar radiation to the precipitation. So we found out that this area right here, the number that explains it is 200, meaning that the received solar radiation is capable of evaporating 200 times the amount of rainfall. The rest of the desert here, right here in West Africa, and then in the Arabian Peninsula, and the Rub' al-Khali, and in the deserts of Iran and India and so on, the numbers vary between 20 and 40. Just to tell you how dry is this, the driest place here in North America, which you know as Death Valley because it is deadly, the number for that is 7. So this is how dry this is. Now we're looking at the eastern part of the Sahara. That is the exceedingly dry area right here. And here is a mosaic of all of Egypt made with the Landsat images, a satellite that flies about 570 miles above the Earth. And a component from these images is in infrared, and that's why all of the water, like the Mediterranean water and the Red Sea, looks black, because water absorbs all of the infrared radiation, so that this is trapped in the water, so we see all water in black. And here, vegetation, we see red because the infrared is reflected by all of the vegetation because of the spongy texture of the plants and the amount of chlorophyll in the plants, and that's the Nile Delta and the Nile Valley right here. This is not the Nile, it's the Nile Valley. The Nile should be a very thin line right here inside the valley. So all the vegetation in the picture that we see is just that one little thing in here. Egypt is a desert country. It is over 96% desert. The area that we're interested in is right here, just south of Kenna, or the Kenna bend in the river, the meander right here, and north of Aswan, which is right here. This is the site of the high dam of Aswan, and this is Lake Nasser south of it. So the area that we're interested in is right here, and we'll look at one computer-enhanced image from the satellite of this particular area to see a little more details. It's going to be focused. Yeah, okay. Okay, there is the Nile channel right here, and this is the vegetation around the Nile, and everything else that you see is desert, and barren desert, totally unvegetated. A very interesting thing that this particular image showed us is the fact that much of the terrain in the area is controlled by fractures. This here is a major fracture right there, which actually there is another one on the other side of here. And these two fractures, that one in here and that one in here, where the land in between just dropped, is the cause for the location of the Nile Valley. And so this fracture pattern is rather significant. This is going up in this direction, northeast, from the northeast going to southwest. There is another older fracture pattern right here, east-west, one little segment in here, another little segment in there, and a major one going from in this direction, all along this, not the light colored material here, but the fracture pattern along which all of these little valleys are located. So the area is quite a bit broken up by these fractures, and we have here a very large plateau. And this plateau is about 300 meters or 900 feet higher than the Nile Valley itself. Now the area that we're more interested in is right here in the center, and we'll go a little closer in to see more details. Here is the Nile again. Don't forget that this picture was taken from 570 miles away. The Nile, and there is the airport at Luxor. So when you come from Cairo, you fly into the airport right here, and then you start heading west, and you go down to the town of Luxor right here. And this area right there is the site of the Karnak temple. And those of you who have been there, I'm sure many of the audience has been there, you remember a little beautiful little pond or lake in the middle of the Karnak temple. It's that little black dot right there. And now we look at this clump of rock right here, which is still higher than the Nile Valley. And the ancient Egyptians selected their site right in this block. It's a little finger that sticks out from the plateau towards the east or towards the Nile River. They certainly are very good site selectors. They went in here because this part is part of the desert. The environment here is desert-like. It is much higher than the Nile Valley, and therefore the floods ended right here. So no water would come to that level. But yet, it is close enough to walk to it from the Nile. So here, you can see a little faint line right there that moves out this way, and that is the Valley of the Kings, where you can find the King Tut's tomb and Ramses and all of these, and they all are in this place. And there is an escarpment right here, and this is the location of the Temple of Hatshepsut. And there is another line in here that goes out that way, and here is the Valley of the Queens. And that leads us to the interesting area that we're interested in. If we look at that from the air, we can start seeing that there is the plateau. This is just haze, desert haze. And there is the level of the plateau, and this is the escarpment that we were talking about, the Temple of Hatshepsut right here, and the Valley of the Queens is right there. It's a very interesting thing it's a story about how the picture was taken. We were flying from Aswan to Luxor, and the pilot somehow recognized me, and he knew that I'm interested in working in this area, and he invited me to the cockpit. I sat behind him, and we started talking, and he said, "What are you doing in Luxor?" So I explained to him things, and he said, "Well, would you like me to go over to the Karnak temple? You can take some pictures from there." I said, "No, thank you, no need. But if you are offering to do something, how about going a little bit closer to the Valley of the Queens? We can take a little bit some areas of the rocks out there to look at the cracks and the fissures and the wadis in this place." He said, "Fine." It was a huge 767, so we went over there. And he started banking, and for me to take pictures, and bit by bit, and I finished up a film roll, and after we landed, I walked back to the plane. My wife and 4 daughters were in the plane, and I behaved as if I know nothing about whatever was happening. As I just approached the seat, my wife said, "What the hell were you trying to do there? Were you trying to kill us all?" Now we come to the ground in terra firma. And the first thing that we observe in here are the rocks that we saw from the plane that are rather level. Now we can see as we come closer, they are much more contorted and broken and tilted and so on. See, there's the fracture right there, and this block, the whole block is tilted. These layers here are supposed to be horizontal. This layer here is supposed to be horizontal, now it's neatly vertical. So there's quite a bit of faulting and fracturing, and that's a significant aspect to our story. Now, as we move a little bit to the right, then we can see some of the original lineations right here, but we can see valleys going up this way and so on. There is parts of the breaking, and that little dome-shaped entrance is the entrance to the tomb of Nefertari. So as we walk into a little bit, you can see this sign which says in Italian, tomb of Queen Nefertari, Min Mut, the wife of Ramses II, and she was the favorite wife of Ramses II. This pharaoh ruled Egypt for 67 years. He died in his 90s, and he certainly was the greatest builder ancient Egypt ever known, and he was also the man of war, expanded Egypt, and man of peace. He made all kinds of peace treaties with people from the north, and Nefertari is known to be his favorite wife. This tomb was excavated by the Italian archaeological mission in the year 1904. Before we enter, we can look at a plan of the tomb, and here you might consider this as your penthouse, so to speak, but we will be going down rather than up. A few steps in here will take you down about 15 feet, and let's assume this is the living room with a nice den on the side. And then you go down for a few more steps, maybe another 13, 12 more feet, and you have a very lovely bedroom in here with 3 walk-in closets. And they really are big. I mean, this can take care of Emil DeMarco's stuff in here. And this. Now let's look. If you look, as soon as you enter in here and look at that particular wall in the living room, what you see is just a magnificent. That's this is the den right here, so to speak, and this part of the antechamber, which is the living room, and you see magnificent paintings and writing up the story of Nefertari and what she has to do to appease all of the gods and the gods of ancient Egypt all along this wall, and in magnificent color. And you really wonder how these colors were composed, and the use of the blues and the reds are just magnificent. All of the colors that ancient Egyptians used are broken up or powdered rocks and minerals from the mountains in Egypt and in some other, even beyond Egypt and Sudan and so on, except blue. Blue appears to have been a kind of synthetic color. But the combinations of colors are magnificent. Everywhere you look, you see magnificent things. Yeah. Don't you wish your living room colors and wallpaper could look like this? Now we walked a little further down on the other side, and here we take a glimpse of Queen Nefertari, and here on her right hand is a mirror. So she's now here. This is the boudoir. So this is all the things that she's going to beautify herself with. So this is a very nice, and with the name, the cartouche. Her name is in here. An interesting thing is that you can start seeing the way she is dressed and so on. It's also very, very lovely way of doing. And here is the end up. The result of the beautification is really magnificent. Now, unrelated to Nefertari, very close to the tombed areas, you have a little village that the artists or the artisans used to live, and they actually went there and lived for months at a time. And their families, their wives and boys and sons and girls and so on, would provide them with the food. So these people would live in one area until they finish the tomb. They don't come back. So their families can see them only at the end of the day. And the interesting thing is that they had, you can see a lot of graffiti in these villages. on the walls near where they sat. And you find this man sitting there and writing up, but we just came back from painting the figures of Pharaoh X, Pharaoh so-and-so. And we made him look slim and beautiful and magnificent. But if you know the reality, he's an old, decrepit man with a big belly and a big ass. But definitely, this does not speak of Nefertari, even because her name itself means beauty. Actually, Nefertari means self-generating beauty, or the woman whose beauty continues to come alive, or something like that. So she's supposed to have been a very beautiful woman. And here is another indication of the artisan's work. First, the way these cotton, very thin cotton dresses are tied down together like that, and the way the whole thing kind of moves about in here. And now the interesting thing also is that in all of her paintings, you can see through her nightgowns. Very nice illustrations in there, and it's a very elaborate artwork. I'm sure there are Egyptologists in the room that can tell you a great deal more about these kinds of things. But here another illustration again, the see-through indications here. Very beautiful, magnificent paintings. They're really something lovely to look at. With Nefertari being led by Isis, and there is holding hands this way, being led. So the ancient Egyptian artisans were definitely romantically sexy in many ways because of all of this see-through and holding hands and so on, even with the appeasing the gods and goddesses. Now, in all of these pictures, you've seen little things here in the paintings starting or peeling off from these paintings. That will give us indications of what is yet to come. This is the goddess Hathor, and this is holding the key of life in her hands. And the reason we're showing that here now is that the paint here is all in pretty good shape. All of this yellow and the Egyptian red colors, and except for the green is really not as good as the rest of the colors. If you look very closely in here, you can see some cracks beginning to show up in the green. There is some of them actually in here, but nothing in the white or the yellow, which means that there may be something in the painted area right here, which may be in the binding medium of the paint that the Egyptian artist used. So the binding medium itself, which in most cases was resin and things like gum arabic from the trees in northern Sudan. So it may have been something that absorbs water easily, either from water from outside coming in or water from inside going out, whichever way it may be. But there is an indications of the fact that this particular paint layer is a little more deteriorated, or there is something happening in here that is not happening in the rest of the view. Now we go down into the bedroom, which is the burial chamber, and you can see the magnificent stars painted on the ceiling, with huge pieces of the ceiling started to fall off. Actually, once in a while you can see a piece of the ceiling that is hanging, and you know it's going to fall off if something is not done to it, and you can start seeing this incredible deterioration in the wall painting. The Schiaparelli, the man that led the Italian expedition that entered the tomb in 1904, had noticed that there's quite a bit of deterioration on these paintings, so that this deterioration must have started in antiquity. And he said that the deterioration must have been due to a huge flood, because I can see a layer of mud in the floor. So he just assumed that there must have been quite a bit of water that entered the tomb, assuming from the Nile, or some flood of water gushing in, and that water had a lot of clay, and when it evaporated, left a layer of mud inside. In many ways, we're not really certain what happened, and that research program, one of the components is to find out exactly what is the cause of the deterioration here. In one of these chambers, you can see here again the deterioration, some of the falling of the stars. And if you look in here, I'll show you a little closer up of this view. You can see the peeling off of the paint right there, and that's the beginnings of things to fall off because they peeled off. We found out that this peeling is really basically due to the deposition of salt right behind the plaster, between the rock and the plaster layer that the Egyptians had used. The first thing that was done was to try to see whether there is a biological component to this deterioration. And here is Professor Arai from Tokyo, who was taking some samples of the wall to see whether there is some biological component, which indeed there are some things, but it is not the major cause. Here is where we can see huge chunks of the wall just peeling off, and there are quite a bit of empty space between the plastered layer, which varies between 1/2 inches and 1.5 inches, and the rock itself. All of this here is Japanese paper that's stuck on the wall just to keep it from falling off, because there is a huge crack right here, and this whole segment might fall down if it's not held together now until we treat it in an emergency way to put it in, and then final treatment sometime soon. Here is an illustration of how this really happens. Let's assume that this is the rock right here on the left, and let's assume that this right here is the plaster layer, and here are the crystals of salt growing apparently from here to here, growing out that way. And if this plaster layer used to be at the junction of the rock, then the salt started growing here and just pushing the layer or the plaster out this way. Another way of here some fibrous growth of salt crystals, and here is an advanced stage of pimples of salt on the surface after the paintings have long fallen off. So there's quite a bit of salt crystallization inside the tomb. When quite a bit of conservation activities had occurred before, that we wanted to figure out exactly where these things are and how many generations of conservation has there been. So we take areas and measure them and this and that, but we also do this by taking inside the tomb cameras that are exactly similar to the ones that are used in the spacecraft. So we have a huge camera in the Landsat satellite that took the picture that I showed you at the very beginning. But this type of camera has long been scaled down in size and naturally in price a lot. And we can take this camera inside the tomb and then take pictures or multispectral images of it. For instance, when here is a photograph taken by ultraviolet rays and one by through infrared radiation, we'll start seeing things that we do not see by the naked eye. For instance, in the ultraviolet image, we'll start seeing things that fluoresce, all of these little specks of red right here. There is quite a bit of fluorescence out of this material that we've not noticed before. There is something peculiar out of this material which might indicate new paint rather than something that from the original painting. So we get all of this information together, and we start talking about the causes of in discussions, sometimes heated debates about what this water might have come from. And there are really 4 competing theories. One is that water would come into the tomb from rain water right up in the desert, which it rains once in a while. Even if it rains once every 100 years or 200 years, that still can do a lot of damage, and goes through the cracks, and we've seen that the rocks up there are highly cracked, and then reach the tomb after dissolving, as they percolate through the rock, dissolving a lot of the salt. As they get into the empty space, water evaporates, leaving salt behind, and it starts building up until it pushes the plaster layer off. Another theory says, no, water doesn't come from above, it comes actually from below. You have rocks that is shattered, and water from the Nile and from all kinds of other groundwater sources and so on percolate through very thin cracks, capillary action through the rock, the shale layer beneath the limestone layer, which the tomb is, and it goes this way and reaches the tomb and so on. And another said, no, it is really, the third one is the humidity from the air. As the tomb, since the tomb was opened, it was left and exposed to the humidity in the outside, and the changes in temperature and changes in humidity, and the rock would absorb humidity from more moisture from the air and cause all of that. And the fourth one says none of these. It is really the water that the ancient Egyptian artisans used in the plaster as they made it. Because if you go to Egypt today, and you see the villagers in the little villages building their own adobe huts and adobe houses and so on from mud brick. They make the mud brick, and then they get a layer of that mud brick mixed with hay to put it on top of the mud brick. But before they do that, they kind of spray the wall with a lot of water so that it will be wet, and when they put the plaster on it, it then stays on. So the ancient Egyptians would have put in a lot of water on top of that rock before they put the plaster layer, and the plaster layer would have at least 20 to 25% of water in it anyway, and this is the water, and then they do all of their paintings and leave the room or seal it, and then the water, which wasn't there, starts dissolving the salt from the rock and comes back towards the plaster and does all the damage. So there are all these competing theories that to this day we don't really exactly know which one is the most effective, and the study is supposed to do all of that, and there are indications that we have now, but there is nothing final in our hands. And the most significant aspect of all of that is that the gentleman that will be responsible for the great artisan that is responsible for the restoration, Professor Paolo Mora from Italy, cannot really do it until we tell him where the water is coming from and what is it that we have to do to the paintings in this manner. So one of the things that one wants to do then to do this, to find out what the components of all of these waters might be, we go to a gentleman that believes that he owns the earth, and we talk to him about what could be done in this particular case. And the one answer to the question about the amount of rain would come from making a topographic survey of the area. Why? Because one of the things that we realized from looking at this space image, which is identical to the other one, but now it is in computers, and if it is in a computer, we can color it any way you wish. So we color the vegetation green. So we had the view showed us that this escarpment right here separates where the Temple of Hatshepsut and the Valley of the Queens from the rest of the plateau, meaning that we do not have to worry about rainwater collecting from all of these drainage lines. We only have to worry about the area that is from this escarpment down to the tomb, which is great news. Therefore, we confine our studies to just a little bit of area here, which is about a square mile only. So going back to the view from the ground, and if we're looking at the area of the tombs right here, and Nefertari's tomb is right there, and there is the hill up here. So if we study this area and make a topographic survey and make a very good topographic map of this whole region, then we can make a hydrologic model of the region and figure out what kind of water we'd seep right here. Right before the lecture, I was talking to a colleague, Bob Bisson, who uses groundwater models to look for potentials of groundwater for drilling, actually, so you get water, fresh water from the ground. And the models that we're using are all exactly the same. We want to figure out, in this particular case, though, that we do not have here any groundwater at all, or we're hoping that there is not much groundwater in here. This takes into account the valleys in this area, the amount of rainfall, and then we can ask the question, what does it take for rain, for water to reach from the top of the tomb all the way down to the bottom, which is about 30 feet. If it takes, say, 1 meter of rainfall, then we don't have to worry about rainfall, because we know that no such thing. It does not rain in these amounts in these quantities at all in this part of the world. But if we find out that if there was an accumulation of 2 inches of rain in here, then rain would reach from the top to the bottom, then we have to worry about rainwater and have to figure out ways to hold that rainwater away from getting into the tomb through the cracks. So it becomes a very essential component to the research. So we get a surveying team, and we did in this case a great surveyor by the name of Robert Cameron and his 2 sons that became the experts to make the topographic map. And we go onto the site and we discuss the geology and what are we doing this for, and what are the places that we want to do about it, and start moving around the terrain to case the joint, so to speak. So you could just walk up the valleys and walk on to figure out what is it that needs to be mapped in this region. And the mapping is done by advanced methods, space age technology, We have all of the equipment with us. We go to a laboratory that was established through the joint cooperation between the Getty Conservation Institute and the Egyptian Antiquities Organization, a place that we can put all of our equipment in. And because it is really the site of all the scientific investigations and all of the computers and so on for the whole study. So we take all of the surveying equipment over there, and then we start out in the fields. And here we can see the laser ranging equipment that is done simply by taking an instrument that actually sends a laser beam to a location. And that location, if it has a laser reflector, then the laser beam would be reflected back to the source, and it comes into some other area in this source, and then you can measure the range, so the distance, so to speak, and the angle from which the line came. So you actually measure both the horizontal distance and the vertical distance between the two very swiftly. It's not the way that used to be the surveying in the past, and so that you can have the surveyor standing in here, one of the members of the team doing all of this research, all of the calculations, and the member of the team going up to specific points up the hill to get these readings of topography, and naturally need a communication system, so you move them back and forth and so on. So it's starting the communication system, and naturally it's not, the other end is not hearing what is happening in there, and you're asking back, or what do you want? I told you to move to the other location. Well, you say, I can't hear you, so it's still. But it works out in the end, and here is the correlation at the very beginning of the research in the shadow of the temple of Hatshepsut. This, by the way, the layer of shale that is in the case of Nefertari underlies the limestone in which the tomb is located. So if we are in the location of Nefertari, we would have this is the surface of the earth. This is about 30 feet where the burial chamber of Queen Nefertari is, and right underneath that is the shale layer that is now here exposed on the ground. And the reason that's exposed here and not in the case of the Queen of the Valley of the Queens is that the fault, the crack that actually bounds the escarpment in the Valley of Queens has dropped down. So meaning that the rock has, in the east of the line of cracks or the fault, has dropped down. So that the measurements continue to be made, and with making specific points from where most of the measurements are related, because all of that has to be tied later with computer. There is one of these retro reflectors to find out the exact locations. Other instruments are used by the team with also the ones that will explain the heights and the distances for you with all of the new surveying methodologies. Now, a few words about the site, because when you hear about Earthwatch, you hear about expeditions in places where there are digs and there is dirt and there's all kinds of things. Not so in the case of the Egyptian desert. Here is the hotel where the team stayed, and it just overlooks the Nile right here, and it overlooks the temple of Luxor. And you know the Luxor temple, this magnificent lotus columns of Luxor. Some of you may have heard about the fact that just on May 2nd, Placido Domingo was singing Aida on the site of the Luxor temple, a magnificent place. And this was the backyard of the hotel, a magnificent garden. Back in here and hidden between the palm trees and the beautiful trees is a nice pool. So don't believe anybody will tell you it was a rough time that we had. And there is the view from the hotel windows, so to speak, with the escarpment that we were concerning ourselves with right here. Again, the Hatshepsut temple would be right here, and the Valley of the Queens there, and there is the big escarpment of west of the plateau. And you can see that the vegetation line is really very thin here between the Nile and the desert out there. What we're looking at here is one of the Sheraton boats that goes up and down between Luxor and Cairo many times a year. A magnificent trip, highly recommended. And this is looking up in the front, and to go west you have to cross it mostly by ferry, and it is very interesting to find out that you don't really know who your neighbors are going to be on that ferry back and forth from the east to the west banks of the Nile, or what your perfume will mix with. And the area there too was so interesting to watch, and all of the people that are doing things. And the craftsman, he is the guy making crates for mostly for vegetable the transport. And here is the alabaster factory, so to speak, making all of the little alabaster eggs and pyramids and so on to sell to tourists. But this is in celebration of a trip to Mecca. You can see this. This is the Mecca black stone, which is holy to Islam. And the owner of this house went to make the pilgrimage. So he's a Hajj, and therefore they decorate his house while he is away. So that's the and most of these people would say that after the Hajj, then their business will prosper a great deal, which in many cases works somehow. And so you walk around the town and you see all kinds of very interesting tourist shots right there. But this particular thing right here is sugar cane. So you buy some and you enjoy it because it's a very delicious thing. And after the day's work, you go around shopping, very colorful things around, or capture a smiling Egyptian face, or take part in a cross-cultural educational discussion. And one of the things I really wanted to say right here is that all of the above, whatever I talked about right here, was just to give you a hint of the research program. Naturally, I'll be glad to take any of your questions. But one of the upshots of the whole idea is to let you know, or to tell you that when and if you hear soon of an expedition going to Egypt, do not wait for long. Join the team, because I can assure you that it would be one of the most interesting and most rewarding experiences of your life. Thank you very much. I'm sure there are lots of questions. Please.
The Aswan Dam is a magnificent structure, but it is also, to what extent is it changing the ecology of the Nile, and how long will that be affected, how much will that affect the future of the
Very good question. The question is the Aswan Dam, even though it's a magnificent structure and it may have been necessary for Egyptian development, but how does this, what are the effects, environmental effects of that? And indeed, it's a good question to ask in an Earthwatch gathering, but it's also a significant question in terms of what we're talking about. Because some of the people that said that the water may have come to the tomb from below, naturally, the Aswan Dam is behind the water that's loaded by that comes into the Nile Valley from the lake is the source for that, or would be the source for that. Basically, the Aswan Dam was required for all kinds of reasons. One of the reasons that I have heard from President Sadat myself, I had never heard written or spoken of at all, was a matter of security. And I asked him, what security? He said, have you looked at the old Aswan Dam? I said, of course. And he said, do you know how it is supported? I said, not really. He said, well, there are only 2 cement poles right there that's holding it. And to us, as army officers and so on, when we're thinking about this, I mean, one bomb can destroy the dam, and the whole thing will be demolished, and that will be the end of Egypt, so to speak. And so we needed to put a dam. These are the officers that made the revolution, to build a rock dam, so that no one can destroy it with a bomb from there. So that was their strategic. That was a strategic reason for building the dam to them. In reality, the dam was needed for in the southern part of Egypt. The villagers could only raise 1 crop per year, so that the water that was necessary to raise 3 crops would be stored behind the dam. In addition, the most significant is the amount of electricity that was needed in Egypt was so enormous that they had to have a huge hydroelectric source for it, which was the water behind the dam. So all of that is why the dam was necessary. Now, what happened in the meantime? All kinds of things that nobody expected. And so it is really in hindsight that we say, what is it that the dam has done? For instance, another thing that no one really thought about before, is that some of the microorganisms that live in water in general have started dwarfing. It became smaller in size. Because in the past, they used to fly or swim in the Nile water very close to the sun and very close to the air, so there was a lot of aeration and getting a lot of rays from the sun and so on, healthy and big. Now, when they came to the Lake Nasser, the water column is very thick. So the upper layers of the water carry these healthy big plants, or tiny one-celled animals and plants, plankton. And in the lower layers, the plants started dwarfing because they not get enough sun, they don't get enough aeration, they don't get enough oxygen, they don't get enough food. And these little things, when they go through the water, through the doors, they actually go in and lodge themselves between flakes of the soil. And that causes waterlogging because they kind of fill the pores between the soil, the pieces, the platelets of clay in the soil itself. So that's something that no one expected ever at all. Naturally, all of the sardines and the fisheries and so on in the Mediterranean have lessened the amount in there because of the food that used to come to the fish and so on, and from so all of the Eastern Mediterranean has been affected in some way a little bit. And then the water that has risen in the ground in Egypt, also affecting ancient Egyptian monuments, including the things in Luxor. So there are all kinds of pros and cons. In the meantime, if you think about the droughts that have occurred in the Sahel region between 68 and 72, and then most recently that devastated Ethiopia and Somalia and Sudan and parts of Sudan between 1979 and 85, these droughts would have caused famine in Egypt had there not been the dam. So the dam is also a storehouse of a great deal of water. Because of these droughts in these places, the water level in Lake Nasser dropped 100 feet. That is also something that no one has been speaking about. So because of the fact that very little water has been coming from other sources. So even though there are pros, there are lots of cons. And please, go ahead. All right. Please.
For a while, some time ago, in the Egyptian newspapers, they were talking about the underground water level threatening the neck of the Sphinx. And suddenly, this died out. What's happening now?
Yeah, there is quite a bit of water. As the level of, it's not really groundwater, the level of surface water, because usually in geology call it groundwater further down. The surface water is the one that you really, that is close to a few feet beneath the surface. And that level of surface water has risen considerably in most of the towns in Egypt because of the overuse of water. In the area of the pyramids and the Sphinx, because there is a village nearby, and also they say because of the light and sound show, and because maybe of the casinos and around the pyramid plateau and all of that, and dumping water around and the water seeps through, the water has come up to within 1.5 feet of the surface. So that is really too close. And what is happening is that there is also capillary action through cracks inside the Sphinx that they go up. So that's why the Egyptian Antiquities Organization started thinking about the head of the Sphinx. If there is a lot of water on there, water also dissolves salts in the rock, and as it evaporates, very much like what's happening in Nefertari, it starts crystallizing, and in the action of crystallization, it kind of breaks up the rock around. So it powders it, and then any little wind would remove layer by layer, so little flakes of the rock would be removed. That's why the Egyptian Antiquities Organization started thinking about the holder of the neck. The Sphinx in the old, when it was found, it used to have a support for the neck. And that has been removed by archaeologists and so on, and pieces of it are in the London Museum and other pieces and so on. And so they're trying to put it together so that they can give the neck support again, so that there will be less erosion from around the neck. Yes, please.
Does the weight of the water behind the dam has it had any effect on the fractures in the valley of the Nile, or do they expect it to make it fracture more?
Yes, quite a bit. And it actually, in some ways, it might relate to what we're talking about too. Because the fractures, I'm sorry, the question was whether the weight of the water behind the dam has any effect on the area down within the Nile Valley. And the answer is indeed yes. What happens is that water, as it moves through the cracks, some of the water seeps through the cracks, which is good because it's groundwater and we can use it in the desert. But the fact that it seeps through the cracks actually lubricates motion around these cracks. Okay, and now you have introduced an enormous weight, just the weight of the water itself. And the cracked rock starts adjusting to that amount of weight on top of it. And the water that went through the cracks lubricates that motion, so there's quite a bit of shaking, seismic shaking, that was not there before the dam. As a matter of fact, this happens wherever you build a dam, though. Whenever in every case of man-made lakes, we have induced seismicity. Small, not huge, but some seismicity. And that seismicity in the case of Nefertari is quite bad. At least right now, when there are a lot of little things that are hanging, as I said, some of them are just hanging by a thread, and a little bit of shaking like that would make it fall off. So that actually applies or has a relationship to the tomb of Nefertari. Yes, please.